Hey there, everybody. Welcome to the program. My name is Eric Edelman, and I'm coming to you live from the Jim and Linda Lee Planetarium right over here in Prescott, Arizona. And this is the Prescott November Night Sky. So this is our monthly live stream that we've been doing this past year on what's going on in your sky over the course of a year. So the newest show is always going to be the one that's the most relevant, where we're talking about constellations, exciting events that are just happening, like things like meteor showers, what's going on. So you have up-to-date information that you can use just to walk outside and look up and see what's going on. But before we get started with all that, just a few quick pieces of housekeeping. One of those being, if you are watching this on a desktop computer, there's ways that you can optimize your experience. So we're going to be looking at what you can call point sources, a lot of those throughout this show. Little pinpricks of light, these stars dotting their way across the sky. So they're going to be really small points on your screen. The lower your resolution, the harder it might be for you to actually see what we're referencing at different points. So this is a visual that shows you how you would adjust the quality of the resolution at which you're watching the video. Ideally, you want to be at 720 or 1080. If you're a little lower, that's where you might run into problems. Now, if you're on a mobile device, here's a screen for you. This is going to show you how you can adjust the resolution settings on that device as well. So as we're going through the show, if I'm pointing out different stars and you're asking yourself, I don't see anything there, what's going on? Well, one thing that you can try is changing the resolution on your particular device. With that being said, let's put that to the test right now and bring up the sky. All right, so here we are. We're actually looking towards the southwest very shortly after right now. So if you're watching this live, this is just an hour from now. This is 7 o'clock tonight in the southwest region of your sky. Why are we looking there? We're looking for planets. So there's actually 3 of them that are really prominent in the sort of sunset, right after the sun sets in this portion of the night. So if you're early to bed, early to rise, hey, this is a perfect type of sky for you because it's going to be early in the evening. So what planets are we looking at? Well, the one that is lowest in the sky, the first to set, but still a very prominent part of that initial setup is Venus. Venus is always a wonderful planet to see if it's visible sort of at that sunset region or right before dawn, right before sunrise. It's one side of the sun or the other. In this case, it is a sunset object. So this is a really great planet to see because it's very close by in astronomical terms. It's going to be a very easy object to spot because of that. Also because it has this great thick atmosphere, which is very good at reflecting light. And so for those reasons, even without the help of a telescope to aid your view, it's going to be relatively simple to be able to spot Venus if you're looking in the right direction. So southwest around 7 o'clock, it's going to be that bright spot near the horizon. Also, you can see, as we've made Venus relatively big in this planetarium here, or from this planetarium view, it has a phase to it. The inner planets, they have different phases to them that we can visibly see from Earth. The outer planets, we're never going to see those phases because we're always going to see the side that's going to be fully illuminated by the sun. So Venus's phases can be interesting if you do have a telescope. That's the one thing that you would need a telescope to help you with. But speaking of the outer planets, though, the ones that are visible here in this view, those are Jupiter and Saturn, our 2 gas giants. So those follow the line up the sky along the ecliptic. You're going to see Jupiter and Saturn early in the night as well. All of these planets, they're very bright to the naked eye. You're going to be able to see them without the help of a telescope. And when it comes to Venus, you're going to see it till a little bit after 8 o'clock. That's when it sets. Saturn is going to be the next one to go down at 10:27. Then we have Jupiter, which will be setting at 11:44. So there's a little part of the night when Venus is visible, and a little bit more so with those gas giants. So I think it's great to be able to learn where to look when you want to see the planets. That can be a good way to start to familiarize yourself with the motions of the night sky. Another thing that can be interesting is knowing how we're studying these objects. And one thing that's going to be very exciting in this particular decade when it comes to Venus is the Da Vinci mission. In the end of the decade, around 2029, I believe, they're going to be launching this craft that's going to be studying Venus, NASA is, in different levels of detail. And actually, recently, this month, they released a very cool video that goes into a couple of the places of Venus that Da Vinci is going to explore. And so I wanted to share that video with you here. It's just a couple of minutes, but it's going to give you an idea of some of the things that we're going to learn about this fascinating planet.
Launching in 2029, the Da Vinci mission, named after Leonardo da Vinci, is designed to address fundamental questions about the origin, evolution, and composition of Venus. During 2 gravity-assist flybys, Da Vinci will study the cloud tops in ultraviolet light, tracking cloud patterns as they change with time and analyzing signatures of mysterious chemicals that absorb ultraviolet light. Both flybys will also examine heat emanating from the Venus surface on the planet's night side. We will look for geological clues of this planet's mysterious past to paint a global picture of surface composition and the evolution of the planet's ancient highlands. 7 months after our second flyby, Da Vinci will release its atmospheric descent probe. The spacecraft will watch its probe enter Venus's atmosphere over the course of 2 days. The probe will take about an hour to fall through the atmosphere, taking measurements and snapping images down to the surface. These measurements include profiles of composition, winds, temperature, pressure, and acceleration. Key gases will be measured to help us understand how Venus formed and evolved. Some of these measurements may reveal chemical signatures of ancient water. With our suite of measurements, Da Vinci will provide new insights into Venus's atmosphere's complex composition, structure, and chemistry. As the probe nears the surface, its descent camera will capture breathtaking bird's-eye views of the mysterious terrain known as the Alpha Regio Tessera, possibly revealing evidence in the rocks that water once flowed across the Venusian surface. These up-close images of the surface will provide new insights into geologic processes and will help us to understand what it might be like to stand on the Venus surface. An oxygen-sensing student collaboration experiment will shed light on the role of this gas in the Venus atmosphere. The discoveries that emerge from this diverse data set will tell us whether Venus was truly habitable, and the story we reveal at Venus will reach even beyond the solar system to analog exoplanets that will be observed with the James Webb Space Telescope. Venus is waiting for us all, and Da Vinci is ready to take us there and ignite a new Venus Renaissance.
All right, well, welcome back. I just wanted to share that with you because I think it's really fun to see what NASA's up to, that we have these neighboring celestial bodies that are relatively close by to us in the terms of the cosmic scale of the universe, but we still, there's a lot of mystery surrounding them from our perspective. There's a lot that we don't yet know. And so this is going to be another attempt to, dig a little bit deeper into one of the planets. So while you were watching that video, I actually changed our view from our Planetarium software of the sky. So now, instead of looking southwest, we're looking east. So we're looking at some of the objects that are rising around this time of night, around 7 o'clock, because I wanted to point out one particular object that's going to be very interesting tonight, this very night. If you're watching live, this is for you. So we have the moon that is approaching full, and it will get full sort of early AM. And during that time, we'll have a lunar eclipse. So this very evening, we're going to have a lunar eclipse that's visible in Prescott, Arizona. If you didn't know about it yet, mark your calendars now. And it's going to be late at night, but I hope you can watch it. We're going to go over some details right here of what you need to do. If you're watching this after the fact, don't worry. I'll also have some ways that you might be able to watch this as well, though it's not going to be live. So this To get an idea of what a lunar eclipse is, I also wanted to show you another video. This time I'm going to be talking over it though, so you're still going to hear my voice. So we're seeing a view of the Earth and the Moon system. This is not to scale. The Moon is much farther away from us. But what we're seeing is over to the left is the Sun, and the sunlight is coming over in our direction, casting shadows to the right. And so we're going to see this video repeated a few times as we explore this concept, where what happens is as the moon orbits around the Earth, sometimes it gets behind the Earth from the sun's point of view, and that's during that full moon phase, when the side of the moon that we see is fully illuminated. And sometimes when it gets to that phase, we get a lunar eclipse. Why don't we get it all the time? Well, it has to do with how the orbit of the moon is sometimes slightly tilted relative to the Earth-Sun plane. Not going to get into it too much, but yeah, we don't get an eclipse, a lunar eclipse every month, but sometimes the stars align, or the planets and the planet, the moon, and the star in this case, and we get an eclipse. This is going to be what's called a partial lunar eclipse. What does that mean? Well, that has to do with those two words that keep flashing on your screen, umbra and penumbra. So penumbra is the part of Earth's shadow that's being cast that is not complete. There's still a little bit of light that's coming onto the surface of the moon there. The umbra, though, that's the total shadow. That's the deepest part of the shadow, where when the moon falls into that, if it completely falls in the umbra at any point, that's when we get a total lunar eclipse. Now, in this case, the moon is going to go through the path of the umbra, but there's never going to be a point where its whole surface is completely within the umbra. There's going to be a point of greatest eclipse where there's still going to be a small percentage of the moon that's outside the umbra. And so that's why we can't call it a total lunar eclipse. This is still, however, going to be a really, really fun event. And so I'm going to explore exactly what's going to happen with you. So, all right, let's head back to our view of the sky, view of the night sky here. So I have once again changed our view. So we were looking over to the west, or over to the east before that video. Now we're looking due south, and we also changed times. We're looking due south at midnight. So midnight tonight, right when it's going to change from the 18th to the 19th, you're going to have the moon right up there. We're also looking a little bit up. So through this show, we've mainly been looking toward the horizon. Now we're tilting our necks up a little bit, as it were. We're getting about a 30 degree tilt, and we're seeing the moon right in our crosshairs. I've also made the moon a little bit bigger so we can see what's going to happen. So to give you an idea, right around 11 o'clock is when this eclipse is going to start. However, it's not going to be too exciting right at the beginning. So at 11 o'clock tonight, we're going to start the penumbral eclipse. Now that's when it's getting into that part of, it's going to be a little shadowed, but it's not going to be that darkest shadow. When the umbra is going to start to come into play is a little bit after midnight. 12:18 is when the partial eclipse is going to start to happen. The partial eclipse is when parts of the umbra are falling upon the moon. So what we're going to do here is we're going to see time pass. So we're at midnight right now. I'm going to, over the course of 20 seconds, show you what happens when we move from midnight to 2 o'clock in the morning. And that's the time where 2:02 a.m. is the maximum point of the eclipse here. That's when we're going to see the moon mostly covered by that umbra. But I'll show you how that's going to actually appear. So, all right, now time is moving forward. We're seeing the stars and the moon sort of move across our sky as we're still staying looking directly due south. And as we're doing so, you can see this shadow is starting to fall on the moon. That's the umbra right there. We're getting very close to 2 o'clock right now, and I think we have hit it. Okay, so this is the point just about of maximum eclipse, where you can still see sort of near the bottom that there's just a little bit of the moon that's outside of that umbra region. But it still can be a very magical event to see. Even if you're not seeing a total lunar eclipse, you're seeing this object that remains relatively constant month to month in your sky change in what I would claim is a pretty dramatic way to see this shadow fall across it. Not only that, but you do have some nice environmental factors that will sort of spice up this particular lunar eclipse. So where the moon is in the sky is unique. Right next door to it, we have the Pleiades in the sky. So as this lunar eclipse is happening, you can just see the Pleiades hanging out next door. The Pleiades being one of the few open clusters out there that we can see just with our eyes. We don't need the help of a telescope. It's a bunch of baby stars that have recently been born in astronomical terms. A few of those stars in this cluster together that we can visibly see with just our eyes. We don't need a telescope. So the Pleiades is right next door. Also, of course, right next door to the Pleiades, you have Taurus and the Eye of the Bull, Aldebaran. So you have a number of interesting landmarks nearby the moon as it goes into this eclipse. So I think it can be pretty fun to see if you're willing to stay up that late. Again, it's happening tonight. So after that point of maximum eclipse, so we're at 2:02 a.m. What happens is the eclipse heads out in that the moon becomes less and less covered by the shadow until 3:47. That's when the partial eclipse ends, when the umbra is completely off of the moon, and then at 5 o'clock, that's when the penumbral shadow as well has been removed and the moon is back to where it was. So it takes a little bit longer. I'm going to I'm going to speed up time here a little bit, and we're going to head over to the west and back down to the ground, not tilting our necks up so much, to see the moon set at this time. We're going to go to about 5:30 in the morning to completely see the moon removed from that shadow. And there it is. So we're back at our regular everyday moon. But yeah, I would highly recommend if you have the opportunity to see this event. This is not something that happens every day. Though again, if you are seeing this show after the fact, as I know some of you do, you are not ultimately left out of the party. There are ways for you to view this. There are a number of organizations across the world that live stream events like this. And one of them is right up north from us here in Prescott, over in Flagstaff, the Lowell Observatory. They, I know, are doing a stream on this where they are going to get telescope views of this partial eclipse as it's occurring with, I'm sure, expert commentary from them. If you want to see this after the fact, I'm pretty sure that they store these shows on their YouTube channel. So just looking up this eclipse in Lowell Observatory, I should probably give you that information. So, or even if you have seen this eclipse, just comparing it to what you could see from different telescopes can be fun as well. So that might be something to do. So all right, we have this moon that's going to be doing this interesting thing. Beyond that, after the lunar eclipse, we have a solar eclipse, a total solar eclipse. So those are those magical events that you always hear people talking about that change their lives to view them. Here's the bad news. You're going to have to travel to Antarctica if you want to see it. So good luck. It's not going to be visible in Prescott, unlike this lunar eclipse. But yeah, there's going to be a total solar eclipse, the path of totality being over certain parts of the ocean and certain parts of Antarctica on December 4th. So that's coming up. So you still do have time to get in a plane and travel there. Good luck if you're going to do that. Be safe. But, speaking of that time of year in Antarctica, it is really the best time to visit Antarctica when the sun is highest in the sky during that time of year. And why is that the case? Well, that has to do with an interesting shape that I can show you. So we're going to take a look at that. All right, so this is something that if you've seen a number of our night sky shows, you might have seen this before, but I always do love to bring it up when there's a solstice or an equinox that's coming up. So here we're seeing as the sun moves toward its December position, it's lowest in the sky from our point of view. So we get the shortest day of the year, whereas in the southern hemisphere, that's when they get the longest days of the year. So it's good summertime for them. So in the northern hemisphere, it's the winter solstice, but in the southern hemisphere, it could be considered the summer solstice. So it depends on what hemisphere you're in as to how this movement of the sun, which is called the analemma, is going to benefit you. And then there's the point in September where it's halfway between its highest point and its lowest point, and that's called the equinox, equal night. And we have one in March as well, and these help us herald in the changing of the seasons. This is where the sun's position is. If you were to take a picture at the same time each day, this would be the shape that the sun would make over the course of the year as it gets higher and lower in the sky. But that very highest point for us in the northern hemisphere being up there in June. We can't quite see that in this view, but that's up in June. And then the lowest point being down there in December. So, all right, this is just a view of what the sun does, and we're coming up on that uh, solstice, the December solstice, on the 21st. That's when you can expect that to happen. So that's going to be the shortest day when you're really not going to get very much of that sunlight. But all right, so moving on beyond lunar eclipses, solar eclipses, all that good stuff. We're going to go towards some constellations, or one constellation in particular. We're going to focus on Gemini tonight. So we are back east. So we've gone to different directions in the sky. We're back looking in the easterly direction, and it's about 11 o'clock tonight. So in this view, the moon is just a little bit higher. It's risen a little bit higher than we can see. And it's just about heading into its penumbral phase of its eclipse. So, but Gemini is here right front and center. It's starting to rise around this time of night, around this time of year. What is the Gemini constellation? It is the twins. And so we see from these constellation lines, it sort of looks like two similarly looking people are sort of holding hands there in the night sky. And these twins have these unique stars as their heads. So one of those stars is known as Pollux. And Pollux is actually, if you take a close look at it, you're going to see it's significantly orange. So it has this unique orange color to it, and it's a relatively large star. So it's about 9 times our sun's radius. That's pretty significant when you think about how big our sun is, right? One scary statistic is if you were to hollow out the sun, make it empty, and you wanted to throw Earth-sized objects into it, you could fit over 1 million of those Earth-sized objects inside the sun. That's how big the sun is. This object is 9 times bigger than that. So that's pretty significant. Now, Pollux is relatively close by to us, 34 light years, just a hop, skip, and a jump. And that's why it sort of looks as bright as it does as the head of one of the twins. Then we have Castor. Castor is a little bit more distant. It's 51 light years away from us. And when we look at it here, we see one point of light. We essentially just see what we think would be one star, but that's not the case. Castor is not just one star. And to learn more about that, let's take a closer look at the Castor system. So we're actually going to fly away from our planet. We're going to fly up and away, and we're going to explore what exactly this system looks like up close. So as we do so, as we're going to fly over to Castor, take a look at what the constellation lines start to do as we fly through the stars, because you're going to see that it's sort of going to distort as it becomes apparent that certain stars within the constellation of Gemini are a lot closer to us, and some are a lot farther away. And so here we see it. We see some are very much closer by, and some are farther away. Now here are these different stars. Castor A, Castor B, and this one that's not labeled here, this is Castor C. That's at a little bit more of a distance from the Castor A and Castor B group. So remember, this one point of light that we see is when we look up close, it becomes this system. And so Castor A and Castor B are orbiting around each other, and that group of stars is orbiting around with Castor C. So I guess maybe the moral of the story here is we don't have one star as Castor, we have 3. Or do we? If you look closer, you'll know that we actually have 6 stars. So Castor A is actually 2 different stars. Castor B is 2 different stars. And Castor C, that's also 2 different stars. These these stars, like Castor A, it's pretty much impossible for us to resolve those into 2 separate objects. How do we know that they're 2 separate stars? Well, when it comes to Castor A and its 2 components, Castor B and its 2 components, we know it because they are what we call spectroscopic binaries. So a binary being 2 stars, a 2-star system. Spectroscopic talking about how well that we know that. So what we do is we look at the light coming to us from these stars, and we can see that the light over time shifts. That when the star is coming toward us, it's going to look a little bluer. When the star is moving away from us, it's going to look a little redder. And based on these shifts, we can actually tell that Castor A the primary star that we see, something is tugging on it, and those shifts tell that story. So with both Castor A and Castor B, those are actually both objects that have a significant large star, something we call an A star, and then it has a red giant or a red dwarf as a companion, so a little smaller object. So those are Castor A, Castor B. Those are actually 4 objects in total, as far as we know currently. And then Castor C, that's 2 objects as well, but that's not because of a spectroscopic binary system and more of an eclipsing binary system. So binary, once again, 2 stars. Eclipsing, because there's one star that will move in front of the other from our point of view, and we will see less overall light. So the point of light that we see will brighten and dim. It will get dimmer, and it will get brighter, dimmer, brighter, as the objects eclipse each other. And because of that, we are able to know it's not one object. Hey, instead, it's 2. So this Castor system is not just 1 star, not just 2, not just 3, not just 4, not just 5. It is 6 stars in 1. What a deal. All right, so we're going to move back away from focusing on the Castor system to look at the Gemini constellation as a whole. So that's coming into view here right now. And just to remind you where Gemini is, here are those constellation lines. And remember that we are looking over to the east. I can actually even put on an E at the bottom for you as a reminder there. Now, why am I focusing on Gemini in particular for this show? It's because we are actually not going to be doing a December night sky show. And so I wanted to be able to still talk to you about something upcoming in December that's going to be very exciting. We're going to have one of the greatest meteor showers of the year, which is the Geminids. So meteor showers being those times when you're most likely to see these streaks of light go across your sky. And these meteor showers, they're named after their radiant, or where the meteors appear to be radiating from. And in the case of the Geminids, they appear to be coming from around the constellation of Gemini. One thing I'll say here, that it's not always in your best interest to just focus really single-mindedly on the part of the sky in which Gemini exists, because these streaks of light, as you're seeing in this visual, they travel. They move in different directions. They fly across the sky. So the best thing to do when you're trying to visualize a meteor shower, trying to see it, and spot as many streaks as you can, shooting stars as they call them, is to sort of sit back and have this large, as wide of a view of the night sky as possible. So telescopes are sort of going to work to your disadvantage in this unique case. When it comes to meteor showers, you don't want to decrease your field of view. And so with this particular meteor shower, when is it going to happen? It's going to reach its peak when it's going to be most active on the night of December 13th and the morning of December 14th. So essentially after 10 o'clock, roughly, on December 13th, that's going to be when you're going to have the times of highest activity. And so to consider what the highest activity might be, we calculate what's called a zenith hourly rate, or a ZHR. And what that means is how many streaks of light you might expect to see per hour when it's at its peak. And so for the Geminids, it often can be over 100. There have estimates from the International Meteor Organization. They currently are setting their estimate at about 150 per hour at the peak. We'll see if it reaches that. That would be very exciting. Now, a couple of doses of reality for you of saying why you might not see 150 streaks in an hour is because that's if you get a perfect score. That's exactly how many meteors or streaks of light you see or are visibly going across your sky that hour. If you're in a perfectly dark sky, if you're in some place like the Grand Canyon that doesn't have any light pollution, that's also an important component. If you do have light pollution, then some of the dimmer streaks you might not be able to see. If you don't blink and you're always looking at the right part of the sky to see that streak of light, that's also going to be a contributing factor. So while you might not see all of them, though, this amount of meteors per hour is pretty great. It means you might see a few if you're really taking some time to look. Now, one of the bad news factors is the moon that night. So the moon is going to be very close to full. It's what we call a waxing gibbous phase. It's going to be full on the night of the 18th. So remember, the night of the 13th, 14th, or early morning of the 14th is when this meteor shower is at its peak. So the moon is almost full at that time, just a few more days. And so even if you don't have light pollution on the ground, the skylight pollution that the moon provides could minimize the amount of streaks of light that you see. So, good news, bad news. I would say overall it's going to be a really great shower. It's not going to be perfect, but I think it could be pretty fantastic. So I hope you get the opportunity to see it. This is a shower that is made by a unique progenitor object that usually we can track meteor showers back to comets that traverse the orbit of Earth and leave junk behind in that area of Earth's orbit. And so when Earth gets into those areas of its orbit, that's when we see those meteor showers every year. In this case, we have an asteroid that is our progenitor. It's 3,200 Phaethon, which is 3.5 miles long. It's a significantly large asteroid that crosses the orbit of Earth every once in a while, and apparently it's a little messy. It leaves a lot of things behind, but it is uniquely an asteroid progenitor for this particular meteor shower. But yeah, I really wanted to let you know about that since we're going to be off for December. Also, just another point is at the end of the show, I'll sort of mention the future of where we're going with these live streams and where we might be in terms of getting back towards in-person events. So if you're interested in that, stay towards the end of the program. But I'll leave those details for that point. All right, so we're not quite done with Gemini just yet. There's one more thing that I wanted to show you here, which is a deep sky object. We always at least want to give you one. And so this one is located around the knee of one of the twins of Gemini. And it's one thing that we call the Medusa Nebula. My goodness, isn't that gorgeous? So this was actually an image that was taken by ESO, the European Southern Observatory's Very Large Telescope. So they didn't want to pull punches with this name, being very literal. The Very Large Telescope, or the VLT, is actually 4 different telescopes that are each 8.2 meters in mirror size, or 27 feet, and that's pretty significant. Sometimes they work together to get ultra high resolution. So this is a image that was taken by the VLT of the Medusa Nebula. Don't worry, if you look at it, you're going to be fine. You're not going to turn to stone, anything like that. This is what we call a planetary nebula. So there are different nebulae of different shapes and sizes out there. A planetary nebula being something that's actually going to happen to our sun at the end of its life, that it's going to get a little too, its outer layers are going to expand. The sun's going to have a little trouble at the end of its life holding on to those. They're going to sort of slough off into these dust gas clouds that can be illuminated in really beautiful ways. So we're seeing one planetary nebula here, though this one is very far away. I believe it's about 1,500 light years away from us. And one thing that I wanted to point out is how we get these images. And it's not always as straightforward as you would think. It's not just putting a telescope, pointing it in the direction of that object, giving it an exposure time, and just snapping the image. There are different filters, different wavelengths of light in our electromagnetic spectrum that give us different pieces of information. So these telescopes, they take this, images, they take exposures in different filters, and together, combining with their powers combined with these different filters, we create these multi-dimensional images. And so to give you an example, the red color here, that is telling us a little bit about what hydrogen's doing. So that particular wavelength of light is associated with a certain transition of hydrogen, and so that's what that filter is tracking. With the really, really light blue that we're seeing sort of over on the sides here, that's tracking a doubly ionized oxygen. So different colors of light, different filters, are giving us different pieces of information that the scientists put together to study these different objects and learn more about them, what they're doing, what they're composed of, and how the things they are composed of are acting, what they're doing. So it's a very fascinating subject. And I wanted to end with this particular nebula, this particular piece, because after I'm finished talking, we're going to hear from some very smart Embry-Riddle students from this. They're part of the Society of Physics students. So, like their name implies, they're people that are very good at learning about and explaining different physical concepts. And so they're going to get into a little bit more detail on this particular subject. And so they're going to provide actually a demonstration of how this stuff actually works. And so what I'm going to do right now is I'm actually going to turn it over to the SPS. There's a great group of hardworking students for them to provide you with this demonstration. And then after that, I will return to give you some closing comments. But all right, SPS, feel free to take it away.
Okay, hi guys, this is SPS, and we're going to talk a little bit more about nebulas and stars. So what you see in front of you is the Orion Nebula, and you can see the different variations in colors that he was talking about with the red and blue specifically. So nebulas are actually composed of gas and dust, and the red is the hydrogen that he mentioned. To see this more exact, what researchers will do is they'll actually put a red filter right over it to filter out all of the other space and just have the red come through. Likewise, with the oxygen, they'll put a blue filter over it, and as you can see, only the blue light will shine through, whereas the rest of it kind of just sits there. This shows a little bit more about what it's composed of, and inside of the nebula, there's actually baby stars that are forming, and we're going to talk a little bit about that in another demonstration.
Hi. So, like she said, baby stars form in nebulas, and then stars will live a very long life. They will then eventually have a fusion reaction, so they blow up into big red giants like our star will one day. And then once the helium is eaten, per se, the star will collapse in on itself. And you will get some form of a neutron star, black hole, or other kinds of spatial bodies. And it'll become very dense and relatively small. So that is our demonstration on stars. We can, of course, answer any questions alongside with Eric if you have further ones.
Oh, well, I believe that's the demo. Thank you so much to the SPS for giving us that piece of information. I think it adds a little bit of depth to the image that you just saw, the Medusa Nebula that you saw. This is the end of the show, and this is also the last live stream that we'll be doing of this monthly Night Sky series for 2021. And possibly for longer than that. So we are off in December, but as we're moving into 2022, this planetarium here, we're trying to consider how we might be able to bring people back in person, that it might be around the time when we can start to do that. I can't give you a specific date right now, but that's something that we're working toward, and if indeed we do get approval to move forward in that direction, we're going to stop doing these monthly live streams, and instead we're going to work on producing content that you'll be able to see in person, hopefully in the relatively early parts of 2022. It's not going to be January, but maybe a month or two after that is our hope right now. And when we know for sure when that's going to happen, all of our channels for communicating with you, the website that we have, prescott.eru.edu/planetarium, our Facebook, facebook.com/JLL Planetarium, our newsletter that you can subscribe to on our website, which once again is prescott.eru.edu/planetarium. That all of those ways to connect with us. We will connect with you and say, hey, we are going to be opening up at this particular time to in-person events again. This is how you can get tickets. This is when you'll be able to see us. So yeah, I know it's been a really long time since some of you have been able to sit in these really comfy seats and see the stars above your heads. We've missed having you here. We've missed having these shows. And so hopefully if things continue to trend in a good direction with the global stuff that's going on right now, then we'll be able to get you back in these seats soon. So please stay tuned. There'll be more information coming to you from this planetarium shortly. 2022, whole new year, and we're optimistic for what we can do in it. So thanks again for watching this show. I hope you learned a bit. I hope you're excited for the future. I hope you get to see that lunar eclipse tonight, or if you're watching this later on in the future, you see it on some live stream that happens somewhere. But yes, best of luck to you at the end of this year, and happy stargazing.